subscribe and stay tuned. Hi folks, now let's talk about choosing the electrical material for this installation. Here, we are going to install the Leviton 30 amp EVR30 car charger. It runs on 208 or 240 volts, which is very typical in North America, and it runs on 30 amps. So first, let's choose the conductor running from your electrical panel to the EV charger. According to the rule, if the equipment is not marked for its temperature rating, we use 60-degree rating for choosing the conductor. Next, according to the rule, this EV charger will be a continuous duty charger because in any 2-hour period it will run over 1 hour. When you plug the charger in your car for like 3 hours, the 3 hour will be continuous. According to the rule again, for continuous load, we can use only 80% of the conductor's capacity, which means you need a conductor which can carry at least 37.5 amps for this case. Let's check the CEC table 2 for the proper size of conductor we need. So here's the table. As you can see, on the 60-degree column, if you need to run minimum 37.5 amps, you will go to 40 amps. So here, number 8 AWG, it's the size of conductor you need for this installation. Let's come back here again. Also, we need to make sure we have proper voltage drop, because according to the rule, you cannot have a voltage drop over 3%. We check the table D3. If you run 32 amps on number 8 copper wire, on every 1% voltage drop, you can run 7.7 meters, which take consideration of the 3% drop, and you're actually using a 240, you can run a cable 46 meters long, which is long enough for most of the cases. So street conductor number 8 will be the conductor we need to choose. Why 3 conductors? Because we have 2 hots, red, black, and 1 neutral, which is white, plus the bonding conductor. But bonding conductor won't count it here. So it's 3 conductor, AWG number 8. So next, we're gonna choose the overcurrent device breaker. Because it runs on 240 supply, so this will be a 2-pole breaker. According to the rule, if the breaker is not marked for continuous duty, we can use only, again, 80% of its rating. So you use 30 amps divided by 80% gives you 37.5 amps. And we check the CEC table 13 here. If you need a breaker rated for 37.5, which drops right in between here, you need a 40 amp breaker. Come back here. So we need a double pole 40 amp breaker, BR240. Okay. Now you probably need to choose the conduit and connectors for this installation. Because in most cases, you cannot flush mount the EV charger receptacle or the fixed model EV charger. Unless you are very lucky, you have a electrical panel right beside where you're going to install this EV charger. That will be a totally different story. Then you probably can flush mount the EV charger or the receptacle flush onto the drywall. But most of the cases, you have to run a conduit from the panel to the charger. So let's check the CEC table 10A. So in here, you can find the cross-section area of the conductor. So based on the rule, you know the minimum size of conduit you need for installation because you're going to pull the conductor through the conduit. Let's check table 10A. So for AWG number 8, XLPE in this column for number 8 is 28.17. So each of the number 8 conductor, the cross-section area is 28.17 times 4, you get 113 amp square millimeters. After this, we check back to the CEC table 9I, which is the cross-section area of the EMT tubing. Because we have more than 3 conductors need to pull through the conduit, we use the 40% fill. Let's take a look. This is for the EMT. So on the 40% column, if you need 113 square millimeters, with this one 132 is good for, you need minimum tread size 21 EMT. So tread size 21 EMT is commonly known as the 3/4 inch EMT. Will be good for 132 square millimeters for the 40% fill. So which is good for our situation. But personally, I will choose one size up to 1 inch EMT. It's easy to pull, and when you need to upgrade the conductor to a higher capacity, it will be still good for it. After that, we need to choose the fitting, the junction boxes. So according to the rule, in worst scenario, we're going to do a splicing in the junction box. So you have 4 cable comes in, red, black, white, and bonding, and 4 cable goes out. And you do 4 splicings accordingly. So you have 4 marrettes here. That will be a 10 cable count. And then we check CEC table 22. So for the size AWG number 8, each conductor requires 45.1 milliliter space in the junction box. Times 10 gives you 451 milliliter. So you need minimum 451 milliliter for the junction box. And here, we choose the range dryer box standard 2 1/8 depth junction box with the knockout, which provides you 42 cubic inch spacing, so which is 688 milliliter. Let's check out here. Square 2 inch and 1/8 gives you 688 milliliter, which is good for our situation. So for the electrical material, you need a 3C number 8 conductor, either it's Lumex, Tech 90 or AC 90, which is the BX1. And after that, you need a 2-pole 40 amp breaker in your panel. According to the brand of your panel, you may choose different brand of breakers. And you need to run minimum 3/4 inch EMT from the panel to the EV charger. Finally, you need 2 1/8 inch depth square box for your junction. So that is all the electrical material we need for this specific installation. In addition, what I mentioned before, there are many other requirements, like marking and signage of the branch circuit. Disconnect means the choice of the receptacle and the enclosure type and ground fault requirements. Also, for the hazardous location, there are additional more requirements here.